To find the roots of this auxiliary equation, we'll be using trial and error method, and we'll be testing if m is equal to 1 is a root. Now, substituting the m equals 1, we get 1 cubed minus 1 squared plus 1 minus 1 equal to 0, which satisfies the given equation. So, it is confirmed that m equals 1 is a root of this equation. Thus, m minus 1 is a factor of this cubic expression. To find the other two roots, we'll be carrying out the synthetic division. We'll be writing the coefficients of the auxiliary equation like this, and carry out synthetic division by writing the first solution, m is equal to 1 here. This comes as it is. It's going to multiply with 1, and it's going to be placed here. Adding these two, it becomes 0. 0 times 1 is 0, so we'll be writing 0 here. 1 plus 0 is 1. 1 times 1 is going to be 1. Adding these, it will be giving us 0. But this 0 is a remainder, whilst these are the coefficients of the quadratic equation. So we'll be writing m minus 1, which is the first factor, and m squared plus 1 is equal to 0. Now that we have successfully factorized this equation, we are going to be finding its roots. The roots are m equals 1, and when we'll be equating this to 0, we get plus minus iota. So writing plus iota and minus iota here. If you're having a cubic expression, you're going to be finding 3 roots of this equation. One of the mistakes most students do is that they equate m cubed equals to 1, and taking the cubic root, they find only one of the solutions, which is wrong. So you're going to be solving this question by synthetic division, which is going to go like this. You're going to be writing the coefficients of the differential equation above. This is the coefficient of the m squared, which is equal to 0, and this is for the m. Now, we are going to be assuming that m minus 1 is one of the factors of this equation. So, we'll be taking m is equal to 1 and substituting m equals 1 in this equation to see if it is satisfied. In this case, m minus 1 is indeed the factor of this equation. So, when carrying out the synthetic division, we'll be writing 1 here and carry out synthetic division. This is going to be the remainder, and the rest of these are going to be the coefficients of the quadratic equation we'll be left with. Now, we cannot factorize this quadratic equation, so we'll be using the quadratic formula to solve this and find the roots of m. The first root of m is equal to 1, whilst for this, we're going to be using the quadratic equation. When we'll be simplifying this root over here, we're going to get minus 3. So let's write it here. And because it is a negative number here, we know that the under root of -1 is equal to iota. So we're going to rewrite this as under root 3 iota. Now we are going to be solving this equation by factorizing this cubic expression. For that, I'll be using synthetic division, and by using trial and error method, I'll try to find its first root. Let's assume that maybe the first roots are at 1 and -1. So when substituting 1 here, we get 1. So m minus 1 is not the factor of this equation. Let's try m plus 1. This is also not equal to 0, and it is not satisfying. So let's try another values of m. Let's try 2 and minus 2. So m minus 2 is not a factor. Let's try m plus 2. So m plus 2 is indeed factor of this equation. Let's apply synthetic division. We're going to be writing the coefficients of this cubic expression here, and then apply the synthetic division like this. We're going to be writing the first root here, which was found out to be m is equal to -2. Writing -2 here, 1 as it is. 1 times -2 is going to be -2. Adding these. Now repeating the same process. This is the remainder, which is equal to 0. And these are the coefficients of the quadratic equation we are going to be left with. So let's rewrite it. Now, we are going to solve this and find the roots of this equation. We know that it is going to be -2 from m plus 2. And for m squared plus 4 equated to 0, we get